In this section, we will refresh your understanding of how Wi-Fi works. You'll learn about the standard Wi-Fi protocols and the principles of wireless communication. This foundational knowledge will aid in understanding the vulnerabilities inherent in these systems. NodeMQ's open-source nature allows developers to access its firmware source code, modify it, and redistribute it according to their needs. This fosters a collaborative environment where improvements and customizations are encouraged. Integration of Lua scripting. Lua scripting is embedded into NodeMQ firmware, providing an easy-to-use scripting language for rapid prototyping and development. Lua's simplicity makes it accessible to beginners while offering enough power and flexibility for more advanced users. Wi-Fi connectivity. NodeMQ's core functionality revolves around its Wi-Fi capabilities, which enable it to connect to local networks and the Internet. It supports standard Wi-Fi protocols such as TCP/IP, UDP, HTTP, and MQTT, making it versatile for various networking applications. GPIO pins. GPIO pins on NodeMQ boards allow for interaction with external components such as sensors, actuators, displays, and communication modules. These pins can be configured as digital inputs, outputs, or analog inputs, providing flexibility for a wide range of projects. Arduino compatibility. NodeMQ can be programmed using the Arduino Integrated Development Environment (IDE), leveraging the vast ecosystem of Arduino libraries and community resources. This compatibility simplifies the transition for developers familiar with Arduino programming, enabling them to leverage their existing knowledge and skills. Processing power. The ESP8266 is powered by a 32-bit 10-silica Extensa LX106 microcontroller, running at a clock speed of 80 MHz. While this might seem modest compared to modern microcontrollers, it's more than sufficient for handling tasks related to Wi-Fi communication, sensor data processing, and IoT applications. Memory. The ESP8266 typically features built-in flash memory ranging from 512 kilobytes to 16 megabytes. This memory is used for storing firmware, program code, configuration data, and dynamic variables. The availability of ample flash memory allows for the implementation of complex applications without worrying about storage constraints. Built-in Wi-Fi. The ESP8266 integrates a Wi-Fi module that supports both station client and access point AP modes. It features IEEE 802.11b, GAN support with WPA to security protocols, enabling secure communication over Wi-Fi networks. This built-in Wi-Fi functionality simplifies the integration of wireless connectivity into IoT projects. Low power consumption. Despite its processing capabilities, the ESP8266 is designed to operate with low power consumption in mind. This makes it suitable for battery-powered IoT devices where energy efficiency is crucial. Additionally, the ESP8266 offers features such as sleep modes and deep sleep to further reduce power consumption during idle periods. Practical demonstration. Setting up the development environment. To start programming NodeMQ with the Arduino IDE, developers need to install the necessary drivers, libraries, and board definitions. This typically involves downloading the Arduino IDE, installing the ESP8266 board package, and selecting the correct board and port settings within the IDE. Writing simple scripts. Simple scripts written for NodeMQ can include tasks like reading sensor data from onboard or external sensors, controlling LEDs or motors connected to GPIO pins, and communicating with other devices or services over Wi-Fi. These scripts are typically written in C/C++ or Lua, depending on the developer's preference. Exploring example projects, and tutorials available online provide valuable resources for learning and exploring NodeMQ and ESP8266 capabilities. These projects cover a wide range of applications, including home automation, weather stations, IoT security systems, and more. By following along with these examples, developers can gain hands-on experience and deepen their understanding of NodeMQ and ESP8266 programming.